Well, I want to move into the next part of this course, and really we're going to look at three different things. Why are we even having a course like this? What is SQL? And then what are some scenarios that we can use for working with our data? A lot of people think, well, why even bother learning something like this? We already have a GIS, there's already commands. Well, I love to show this slide, that we're all special, right? And everybody, if you have kids, you've seen this, right? There's a seventh place, ribbon for coming in seventh place. So everybody's thought of being special, whether it's in sports or scouting or the spelling bee, we all get participation trophies. So why not spatial, right? In fact, that's what we say, don't we? We say spatial is special. And we have things like GIS Day that confirm. Now I get why we do that, right? We want to bring about awareness to our field in geographic information science. But in saying that spatial is special, right? So why not spatial is special? Well, then we have special software. It's called a geographic information system. We have special wizards that do things, right? If I want to buffer a command, I pop open this wizard and it will work, and it'll ask me all these things of what layers I want to use and how far I want to buffer, if I want to intersect, right? So there's a special wizard that just does that. And we have special formats. We have shape files and geodatabase files and mid-MIF files and all different kinds that are specific to particular vendors, many of which aren't even open to other vendors to use. And we have special tools that go along with that for importing and exporting, and it's specific to spatial. It's specific to the GIS software that we use. Well, why not strings are special or integers are special? See, my friends in computer science and information technology, they don't ask those questions. They don't say strings are special. It's just a data type. It's a string. It's just an integer. It's a data type. It's nothing special about it. It's just like a floating point. And in fact, what's really nice about that is my friends don't get bogged down into the special nature of strings or floating points or integers. They use them interchangeably because the software that they're using and the programming techniques they use just treat them as another data type. But let me ask you, what if spatial was just another data type? That there really wasn't anything special about it. We just think of it as a data type, like an integer. It's just data in a table in the form of a geometry. And you can see this here. I've got some queries I'm asking, and I'm treating those geometries as just a data type. We kind of did that earlier when we looked at the fire stations. So the idea is, if it's just data in a table in the form of a geometry, if I can add two numbers just like I add two integers or two floating points, then why can't I just intersect two geometries? Or if I can trim a string of a few choice characters, why can't I just clip one geometry with another geometry? Or if I can find a date that's between two other dates, why can't I find a geometry that's just covered by another geometry? Thinking in the same way, right? So just like we can add two numbers, why not say, and so in a function called add, right, we pass it two values, 1 and 2, and it'll add those numbers. Well, what if we had something called intersect? And I pass it two geometries called geometry 1, geometry 2, or layer 1 and layer 2. Same idea. I'm using the same syntax and the same structure. So that becomes really, really powerful. So why this course? Well, the reason is SQL is perceived to be hard by a number of people. Actually, SQL is easy. It's powerful. And in fact, I would say query wizards like we see here, where we say this is the query builder in QGIS. By the way, I love it. I think it's great and it's got its purpose, but it is dumbed down. It's really sticking us with just the where clause. So here I'm saying I want to know where the population is above a certain value over here, right? Above 3,000 or whatever value you would want. That's all I'm doing. There's so much more to SQL. So I think when we just teach people how to use Query Wizard, we're raising a generation of GIS novices. And the query wizards really limit our ability to what we can do. There's a lot more power involved in SQL that we can leverage and make use of. Now, I started teaching formally with SQL about 20 years ago. And this was a quote that I had seen that really got me started on this. And the reason was a friend was doing some work in SQL and talking about it, and he got into a bit of a kerfuffle with some vendors who were talking about how you should not use SQL. So this is the case against it. Basically, they said they were talking about using the wizards that we just looked at. So some kind of a wizard like this. It says, anybody can manipulate that and understand the workflow without requiring highly paid, specialized consultants to come in and tweak obscure SQL statements. And they were talking about Oracle Spatial. So we're looking at Postgres, but very similar. But it says, look, Oracle Spatial and the SQL that come with it is not free in quotes. There's a huge learning curve, and it's not intuitive. So this friend of mine, called me up and says, how do I respond to this? So I created a short little SQL video for him. But these are pretty damaging statements. If you want to use SQL, you need highly paid specialized consultants. This stuff is obscure, right? There's a huge learning curve in it, and it's not intuitive. Well, if you ask me, I don't want to do this either, right? It sounds very, very complicated. But the question, is SQL really obscure? Well, it's actually the most popular computer language used to create, modify, and query databases. Again, understand that. It's the most popular language used for databases. Again, we live in this GIS ecosystem over here, but there's a whole big world out here using databases. SQL is an industry standard to query languages used to fetch records from tables and databases and present those records to the user. I mean, that's an actual standard, an industry standard. Is there an industry standard in GIS? Well, we could say one particular vendor is used more than another, but that's not a standard. And in fact, when we talk about standards, SQL was adopted by ANSI and ISO in 1986 and 1987. That means this is an ANSI standard and an ISO standard for over 30 years. Is there anything in the GIS field that has that level of standardization? So I don't really think this idea that SQL is obscure really holds water. It's actually more standard than GIS is. Also, it's not intuitive. Well, look, SQL was actually designed for a specific limited purpose, querying data contained in relational databases. Not only querying, but also updating data. It's a declarative computer language that is very English-like in its form. It uses high-level programming, so it's more user-friendly, and it's also platform independent. Look, if you write SQL, and also software independent, if you write SQL in Postgres, you could probably take most of that same SQL and just copy it into Oracle. And if you're using Oracle in a Windows-based system, you can take that SQL, copy it into Postgres on a Linux system. It doesn't matter. So this is very, very platform independent. And again, we'll see later, it's very English-like. So the idea that it's not intuitive doesn't really, again, seem to hold much water. Also, do we need specialized consultants? Actually, I would say that the GIS field is the one with the specialized consultants, people who understand GIS, but databases that use SQL, they're based on server-based applications like Oracle, SQL Server, MySQL, Postgres, what we're using, and many others. There are also many, many personalized SQL databases like SQLite. Those of you who have Windows operating system have been using Microsoft Access for many, many years. And each one of these vendors, whether it's Microsoft or Oracle or Postgres or anyone else, has developed plugins for spatial constructs using the same kinds of standards with SQL. So there's something called Oracle Spatial. There's something called SQL Server Spatial. There's something called PostGIS, which we've already loaded. And this database, this little personal database of SQLite, has something called SpatialLite that was developed. So a lot of products on different platforms are out there that many people use. In fact, it's really become ubiquitous. So what's the conclusion? The conclusion is SQL is the standard language for relational database management systems. It's a recognized standard in computing. So we're not going to get away from that. This is something that lots of people know. It's also the de facto language for updating, deleting, requesting information from databases. And this one, I think, is most important. The SQL ecosystem dwarfs the GIS ecosystem. Here's the reality. Go to any hospital, the billing system, the medical records are handled by SQL databases. You call up an airline, your reservation is going to be held or taken and managed with an SQL database. Your financial transactions, when you talk to your broker, they're putting that stuff into SQL databases. SQL is literally everywhere. GIS are in a few places when we start to think about it. So the nice thing is, if you can find SQL programmers out there whose skill level is just amazing. Parts inventories for warehouses are using SQL databases. So we just need to teach them some of the spatial part, and they can really run with all the knowledge they have of SQL. So I don't really buy the whole premise of this idea of SQL, again, not being useful, should be avoided, and let's really focus on GIS software, which is special. And I think what we're going to see for the rest of this class is how easy and flexible and adaptable and powerful SQL is, especially when we begin to add spatial constructs. So let's start with just a little bit of an appetizer, just to whet your appetite. You can just follow along here, just watching me. I'm going to show you how to do a little more of this manipulation where we'll copy and paste our commands. So here's the first command, select star from TC parcel. So these are my parcels, again, that you can see in QGIS. And what I'm going to do is go into the database manager. And I'm going to say select star from TC parcel. TC parcel. There we go, and that's just going to take a second. So that's all the data that we see here. Okay, and I'm looking at that in table form. I can also ask the same question inside of pgadmin. So select star from TC parcel. And I can hit the button, and that'll run the query, and then I have my data, and I can click on this to view the geometries. But let's view the geometries in QGIS. So here I'm going to say, let's load a new layer, and let's call it query result. And we'll load that. And what you'll see now is it has, close this up, and we can zoom to this by right-clicking. We've now selected them, and they're kind of green in color. That's fine. We'll use the green. And this means that star means select everything, and the table name is TC parcel. Let's use this next one. Select prop class from TC parcel where the acres are greater than 44. So we'll come in here, and I will paste this. So select the prop. So all I want to know is the property class where the acres are greater than 44. And those are the property classes. I can also say select star and get all the data. And that's done as well. Well, I can come back into QGIS and under my query results say update the SQL layer as I right-click on it. And let's change this here. Let's say select star from prop class where the acres are greater than 44. And it just made that selection. And take a look at our green map here. I'm going to just move this out of the way, and I'm going to say update. And now if we zoom in a little bit, you can see a lot of those green parcels have gone away. I can say where the parcels are greater than 144. We'll execute that. And then let's update it. And look, a number of them also go away. So right inside of QGIS, we're talking to Postgres. This is also a fun one. Let's copy this. And I'm saying select TC parcels dot star everything from the parcels and the flood zones where the flood zones and the parcels intersect and the flood zone is equal to AE. So let's come in here and I will paste it. And again, what's really nice about QGIS is you can see the highlighting here. Makes it very nice. So this is actually performing an intersection. It just completed. And let's move this. I don't know which ones we're going to see. Let's update it. And that's done. And here we go. So here's a couple of properties here along the shoreline that, again, they intersect the flood zones. You put the flood zone in, but not only do they intersect the flood zone, they have to intersect the AE flood zone. So if you look over here, this is not the AE flood zone, so there are no parcels selected green, but in here we do have the flood zone selected. So you can see where they intersect. So that's the AE flood zone touching parcels. Think about what you'd have to do with a traditional GIS in order to perform this. First, you'd have to do some kind of a select by attribute with a wizard. Then after that, you'd have to do some kind of an intersect, select by location, again with a wizard. So let's talk about this one. And this will be the last one that we'll do. And again, it's just to whet your appetite. So we'll come in here and paste this. So here I want to select all the parcels, from the parcels, the flood zones, and the fire stations. This is a 3-table join where the parcel geometry intersects the flood zone geometry, and the flood zone geometry is AE, and the parcel's assessment is greater than 500,000, and the distance between that parcel and the fire stations is under 6,000 feet. So we can execute this. That's done. It happened in just merely a second, and then I can update that. Let's bring in our map. And you can see a lot of them went away, but not all of them. Let's turn the fire stations on. And you can see some of the ones that are nearer to the fire stations. And in fact, let's make it less than 1,000 meters. Why don't we try that? And let's hit the update again. So now more of them have gone away because these are greater than 1,000 meters or 1,000 feet from the fire station. But again, think about what we'd have to do in a classic GIS. We'd first have to find the flood zones that are AE, select by an attribute. Then we'd have to do another wizard, select by an attribute for assessment greater than 500,000. Then we'd have to do an intersect where those selected features intersect one another. Then after that, we have to do another select by distance where they're under 1,000. This to me is much more English-like. So my hope right now is that you're saying, wow, this is actually a lot cooler than I thought. Let me stick it out and watch to the end of this course because there's a lot to learn. So we're going to dive in a little bit deeper now into SQL.